Alright, so this video is going to be about COPs and how we can run external Python processors. This is actually not just because I want to write code in Python, it's actually because I want more control over how I manipulate the pixels. Specifically, using Python, we can change other pixels of the image than the ones that are currently being processed. I'm not sure how to do this in a cop vop because it seems like it's like a shader where you can only access um, the pixel being processed. You can only change that pixel. You can't change other pixels. So you can use stuff like convolution filters, but you're still sampling other pixels, but you're not changing other pixels. And why have I thought I wanted to do this? Well, I've been kind of looking into dithering a little bit. I actually can show off. I did do the what's it called, the Bayer dithering algorithm in COPS. So let me just kind of show you my cool new Bayer dithering node here. So let's just bring in an image. Yeah, this default one's fine. And we can call it Bayer dither. Yeah, let's go to composite view here. Yeah, so yeah, there's a bunch of different options here. There's downsampling, the order, threshold, which will reduce the blacks. Feature size will sort of, well, you can sort of see it sort of makes more of a grid pattern. And then there's a bunch of different color modes here. So this is just the original image being passed through, color mode 0. Color mode 1 is just a tint. You can change this as needed. Color mode 2 is basically doing a ramp based on luminance. And you can change the stepping. So I think, yeah, the minimum value, it'll go pretty fluidly through these based on the luminance. And if you set a higher step value, it'll sort of quantize those colors. You get fewer colors in the result. Color mode 3 is closest match in a palette. So you can make a custom palette here. And actually, I do kind of want to show how I did this because this was actually really tricky, and I'll get to that in a second. And by the way, I will get to the main topic I was going to talk about, which is external Python, but I wanted to talk about this Bayer dithering effect first. And then color mode 4 is, what is it, quantizing the color. So it's pretty straightforward. It's just sort of, it's not really detecting the most common color. It's actually just sort of rounding all the colors to a certain step. So if you wanted to find the most common color, again, that would be something you'd use the Python script for because you can analyze all the pixels in one go. I think it is, you know, I don't know, probably possible using COP techniques to do something like that, but it's not so easy. Probably gonna have to make like intermediate textures to store your data, and it's just I don't really like doing that. I'd rather just have a script which can read all the pixels. But first of all, let me talk about this color mode 3 and the palette here. So if you go into this network here, the COP2, it's basically just one big, snippet, and then a bunch of parameters will plug into it. And if you want to, let me just allow it in contents. If you add a param here, which is like, you see the types here, they have these like color array, float array. So what I really want is a color array because that'll let you add as many colors as you want to your palette. Let me just make sure we're recording. Yeah, we're good. So, but if you add this color array and you plug it in, let me just do this real quick. So then we go back to our VopCop2 thing. And if you see down at the bottom, it just says parm. There's no color array UI here. So essentially it would seem like that just doesn't work. But I'm like, well, I want to make a palette parameter. So how do I do that? And so I made there's a little hack basically. So what you do is you basically, this is a subnetwork, right? It's a COP level subnetwork turned into an HDA. And so on this, you have our own parameters. And then we have this palette here, right here. So this palette, this is a multi-parm block list. This is how you make like lists in your HDA parameters. You make a folder and then change the type to multi-parm list. And then inside that folder, you add whatever thing you want to be able to add or remove. In this case, I added a color here. And then basically, there's actually the mechanism that I pass this into the VopCop is via an invisible parameter. So there's one called palette string here, which I can unhide. Let's see here. Where is it? Oh, I need to apply it. My bad. So here's the palette string. So if you see, it's basically all this data that's just serialized. And this is happening automatically. So how I do that, if you look at this color node right here, there's a callback script, who.phm serialized palette. This is just how you write, like if you want to run a Python script when a parameter changes, you just do this, who.phm stands for Python Houdini module, and then serialized palette is my function, then I'm passing it kwargs. And then you go into the script section and this Python module is here. If it's not there, you just go to event handler, click Python module to create it. And I just create a method. It's passed keyword arguments. And then in here, what I'm doing, getting a handle on the current node. And then I'm reading the count. So this right here, if you mouse over, you can see parameters palette. So I'm doing node parameter palette eval. That gives me the number. And then just using this little snippet, I'm basically just turning it into sort of like, I don't know, this is sort of a custom data format. Like I was thinking of using JSON, but it turns out Vex kind of only supports certain kinds of JSON data structures. And this was just easier. Basically, I just take each color here. I do those numbers separated by commas, and then each color is separated by a space. And then so basically, whenever one of these colors is updated here, for example, you'll see right in the bottom there, it just instantly changes, right? Via that callback. Now, there's one issue. As you see, when I add a new color, or say I delete this one, so I can delete all the colors here. The palette string doesn't update, and I couldn't figure out how to make a callback run on this palette here. So what I ended up doing is actually making just another button called update palette, which calls the same method, so you can always just click that button and it'll just do it manually. But then how do I actually use these values? Well, if we go in here in the VOP-cop2, so basically, I think, yeah, I just have like that bound to a parameter. It's a string parameter using this expression here. And then in the script, let me see where it is. Right here, I just basically take that serialized string and I split it up into vectors using this Vex code here. Yeah, so I wrote a snippet about this on my wiki.dissonantinfo, random notes. If you see in the Houdini section, there's a new entry here which says how to do this. If you ever want to use list parameters in your VOP cops. But anyway, moving on to something completely different, not having to do with Bayer dithering, is running standalone Python. And sorry, what I was getting to regarding dithering is why I wanted to do this. So I was looking at different dithering algorithms, right? So we see there's all these cool ones. And I was like, okay, I like this Floyd-Steinberg one. I'm trying to figure out how to do that. I think it looks kind of interesting. I wanted to try implementing it. By the way, I also implemented random. So if you want access to my random dithering and Bayer dithering cop nodes, you can go in my wiki. Sorry, I think it's in, if you go to the wiki here and then you go to Houdini tools, it's going to be in this cop shelf. You just download that shelf. Anyways, so I started looking at Wikipedia. I'm like, okay, so let's look at the Floyd-Steinberg dithering algorithm. So basically, here's the pseudocode for it. And you can see that it's essentially setting other pixels. And I noticed this and I was like, wait a minute. I can't do this in CopVop. I can only modify the pixel that I'm processing. How do I do this? And I tried poking around the CopVop, see if there's a way to assign the values of other pixels. I couldn't figure it out. If there is a way, please let me know. But yeah, and then I started looking at Shader Toy. I was like, well, maybe somebody figured out how to write this into a shader. So I look at some of these on Shader Toy, and I can look at the description here. So see, it says each pixel's error should flow into the next, but I'm getting close enough by looking at the previous few phrases. So he calls it fake because he's not doing this, or they, I should say. And then here's another one. Maybe I should stop making shaders that rely on progressively accumulating pixel data. Yeah, so it's a difficult thing to implement in a shader. So I was thinking, well, if I just had a Python processor that could literally, like any Python processor that goes through the image can do this without any problems. So how do I do that? So I hacked around for a while. I made a lot of misdirections. I was going for a very hacky system, and then I found out a way to do it that's actually pretty simple. So I'm going to show how to do that. Okay, so on to the part about the Python processor. So what we're going to do here is go to File and New Asset and Python, and we'll call this tutorial Python processor, and in the network type change it to compositing filter. This is because we want to read an existing image, apply an effect, and do an output. If you choose generator, that'll probably work, but you can't read any inputs. There's no input slot in there, so let's just do filter here. Okay, I'll just apply and accept it, and then we'll do, what would we call it, tutorial Python processor here, and I can plug this in. Hopefully my Houdini is okay. Yep, it looks fine, but there's an error. So what's the error? Cannot find shared object file. Something with the CPP inline. Looks kind of scary, but if you right click on this, you can go to type properties and then go to code. Or actually, I'm just going to do edit Python source and external editor. I prefer doing it here. So I don't have this inline CPP. And if you see what this default Python module is doing, it has a cook function, which is a cook callback, which is something that's not really available in normal HDA callbacks, is a proper cook callback. So this is really cool. It's doing something with inline C++. It's doing a pre-multiply. I don't want this, so I'm just going to delete this. It doesn't work anyway, so I'm going to get rid of that. And at this point, this should work, but it's giving me this error: the attempted operation failed, invalid sequence string size. So that's an error that hung me up. I actually tried recording this, and I kept trying to get past this error, and I couldn't figure it out. So essentially what we're going to do is just ignore it. And I can show you something here. So if I bring this node into the Python shell and I just call cook with force is true, it'll actually show my input image here. As soon as I pan, it goes away for some reason. Yeah, it's pretty odd. So I don't know what's going on there, but it seems like when I wrap this inside another subnetwork, the issue seems to go away. I don't really know what's going on there, but just bear with me. So what I'm going to do is create a subnetwork. And I'm just right away going to, well, actually, I'll plug in my input to this, and I'll create it as a digital asset. Create new. Let's call this tutorial Python processor wrapper. So we have two HDAs here, right? We have this wrapper, and then we have the Python filter cop. So I'm going to just plug my processor in here. And then in my wrapper, I'm going to go to my parameters here, and I'm going to just make that button just to do the force push. So I'll just do Houdini, Python Houdini module, force cook, keyword arguments. And this is just calling a function, which I'm going to define myself here. In the scripts tab, I'll create a Python module. I'll call force cook with keyword arguments. And then I'll say node is keyword arguments node. And I'm going to do node. Let's actually get in to find the subnode. So the tutorial Python processor 1 cook. Oops, I'm missing an underscore there. Cook with a force true. And so now when I click this button out here, this will force cook that input node in there. So there's some sort of error, cook error incomplete. I think so. This, I noticed that you need to put like a null in, which is a little weird, but just this thing doesn't like to read directly from the subnetwork input. So if you put something in between it, it likes it a little better. So as you see now, I do have this click. I can click the button to force cook. And it's a bit more stable now, which is interesting, right? And if you notice when I toggle the inputs, it's automatically cooking. So right now, this is just a pass through. It seems like, well, what's so interesting about this? But you realize that right now our pixels are all going through this Python function here. So what I'm going to do is let's actually just make sure that I have the up-to-date file in here. Go back here. Yeah, so when you go in and out of this HTS, it gets screwed up for some reason. So I'm not sure why, but I just need to recook it. This is fine. So now let's look at this Python script and how we can use this to use an external Python. We'll call an external Python script through here. It's actually not too tricky. It's actually pretty straightforward. So we're going to open our wrapper type properties here, go to the parameters, and just create a file parameter, and we'll call this script. And then this label, let me just call this force cook. Okay. And now we have this script parameter here. That's all I need. And now in our what do we call this? A Python cop filter. I need to read this script parameter. So let's see. In our cook function here, I have a reference to the cop node. So I'll say like parent is cop node parent, and then the script path is parent parameter script eval. So that's going to give me a string. And I did have a little snippet saved here, which is how you can take that absolute path of a script and then just load it in. So I'm just going to copy paste this right here. I'll move these imports to the top of the file. Give me a second here. So script path is cop node parent parm script evals. Cool. We don't need any of this. And now basically, if you read through this, our script gets added to a variable called script. So at this point, I can create an external Python script. So what I'm going to do is I actually have a script created. So this is just let me just open this in Sublime actually. A really simple script. Right now, this is just a pass through. So it's given some pixels, and it just returns the pixels. It says here each pixel is an RGBA array. I'll get to that. Because if you see in this default Python cop filter, it's parsing out the colors as this arrays thing. So this actually, these are actually, it's complicated. It's an interleaved RGB. So it's sort of like, if you think about it, it's like RGB, and it's all in one array. So this is multiple. So what we want to do, just to make it easier to process, is split this up into like an array of RGBA objects, one representing every pixel, right? Now it's interesting, we don't have UV coordinates here, so you could probably rebuild the UV coordinates using the resolution of the image. I'm not going to do that right now, but hypothetically you can do that without too much difficulty. One thing I do want to point out, this all pixels is string. Doesn't actually return the data type we need. So let's see here. Right, here's the Houdini docs on this. If you call all pixels, so to get the contents of a plain and input node, call all pixels or all pixels of string. The former returns a series of floats, while the latter is faster and returns a binary string containing the input image data in the requested format. So this is the default, but if you try and read these values, they're like not normal colors. So really, we just need to use all pixels and then this other corresponding function down here. So these are just going to be regular numbers in 0 to 1 range. And I actually have a version of this from before, which is going to do, it's basically going to do that conversion like I mentioned. It's going to take that color list, an alpha list, and turn this into an array of like RGBA, etc. And it's kind of important that these are arrays and not tuples. You could use tuples, but I think it's easier to have them as arrays because arrays are mutable, and they are mutable. Tuples are immutable. So that makes it a little easier to do the programming because you don't have to like return a new object from here. Like for example, I could say just like pixel 0 like 0 equals 1. So, and now I've just manipulated this because this is mutable. Or I should say the first entry in this list is mutable. Anyway, you couldn't do that if those were tuples. You'd have to return it. You'd have to build a new list of tuples, etc. So anyway, this builds arrays here, and then I just basically modify those arrays with my script. So I'm going to say script.run. That's this run function I've defined here. And now what I want to do is take these RGBA arrays and turn them back into the format which we expect. And if you, this is only outputting C. I haven't messed around with outputting alpha. I mean, I'm pretty new to this whole thing. You can read about the docs about Python image filtering. Houdini does have some docs about that, so I haven't dug too much into it, but this alpha isn't really used essentially right here. But anyway, so yeah, this is just converting it to an easier format, running the script, and then outputting the data. Now if we go into Houdini here, we don't have a script path, so let's go to our desktop. Or was this one, test.py. And there is our stuff, and that's super cool. And like the cooking is still automatic, and every time it cooks, it's just running through our external Python. So if we want to prove this, we can say for pixel in pixels, pixel 0 equals 1.0, and then we'll return pixel. So this is just doing a red tint, I should say. And there we go, there's our red tint. So it really is working, which is kind of cool. Now, obviously, I'm only scratching the surface of image manipulation. This is like, you know, Python's like a super deep ecosystem for image processing. Obviously, I mean, I feel like it's very different than GLSL and just in terms of the syntax. So it's easier to rewrite shaders into Vex actually. But yeah, so I'm still trying to get the hang of Python. I have mixed feelings about it. It's a little weird in terms of its syntax is kind of unique. But anyway, this is kind of cool. So yeah, now you can use your external Python scripts in COPs. Yeah, and there you have it. So that's going to be it. Oh, and so that's interesting. So I got a little screwed up. But okay, yeah. So I will have this node on my random notes, or sorry, on my Houdini tools cop shelf. So if you want to download that, just go ahead. Yeah, and I hope this was useful. Pretty niche topic, but yeah, definitely easier. Not a lot of info about it, that's for damn sure. All right, cheers.